Specialized network devices. Now, there are many different types of network devices out there, and there are lots of them that are outside of the standard routers, switches, hubs, bridges, servers, and workstations we've already talked about. Other devices out there are going to perform specific functions that will improve our usability, our performance, or our security. Many of these devices include things like VPN concentrators, firewalls, proxy servers, and content engines and switches. We're going to talk about each of those in this lesson. The first one we're going to cover is a VPN concentrator, also known as a VPN headend. Now, a VPN is a virtual private network, and it's used to create a secure VPN or virtual tunnel over an untrusted network like the internet. If you're at home and you want to be able to dial into your office, either over a dial-up connection or over the internet using broadband, you can do that using a VPN connection, which creates an encrypted tunnel so nobody can see what you're doing, but you get from your home to your office securely over that public network. Now, the device that terminates this VPN tunnel is called a VPN concentrator or VPN headend. This allows this device to have multiple VPN connections coming into one location. Now, if you have a good firewall, most of them will have this function. But logically, when it's doing this function, it's still functioning not as a firewall, but as a VPN concentrator. So keep that in mind for the exam. The VPN concentrator is this function. It can be a device or part of another device like a UTM or a firewall as well. Now, if I have a headquarters in Washington, D.C., for example, and I have two other branch offices in Los Angeles and New York, I can actually tunnel all the traffic from Los Angeles and New York back to D.C. using these tunnels. In this case, I would use what's known as a site-to-site tunnel. These would allow those locations to connect back to my headquarters securely through the internet and save me the cost of having to use leased lines. Now, when you hear the term VPN headend, remember, this is a specific type of VPN concentrator, and it's used to terminate IPsec VPN tunnels within a router or another device. Again, we're going to talk more about VPNs and VPN security in a separate lesson because they're really important to the security of our networks and there's a lot to cover there. The next thing we're going to talk about is a firewall. Now, a firewall is a network security appliance that's placed at the boundary of your network. Firewalls can be either software or hardware, and they come in stateful and stateless methods. We're going to talk more about firewalls in depth in their own video, but for now, I just want you to remember that firewalls allow traffic to go from inside your network to outside your network, like to the internet, and they can block stuff coming from outside your network, like the internet, to the inside of your network. Now, on the screen, I have three different ways to show you how firewalls will look inside of network diagrams. The first way is what Cisco likes to use. They call this a PIX firewall, because that's their brand of firewall, and it almost looks like a diode with a triangle and a line on it. A diode is essentially an electrical component that only lets things go one direction, which is why they represent a firewall in this way. Now, the next one that some people will use is just to put a brick wall in their diagrams, and that will represent a firewall. The third thing we can use is have your firewall combined with your router and basically make it look like a router with a brick wall wrapped around it. These are the three ways you'll see it in network diagrams when you're looking at firewalls. All three of these icons are used to demonstrate that there's a firewall there inside your diagram, and most of the time what you're going to see is that brick wall. That's pretty much the standard these days. Besides a regular firewall, we have these things called NGFWs, or next generation or next gen firewalls. These can conduct deep packet inspection at layer 7. A regular firewall is really going to block things based on your IP address and maybe the port and protocol. But these next generation firewalls, they can look through your traffic to detect and prevent attacks. They are much more powerful than your basic stateless firewall or even your stateful firewalls. They are continually going to be connected to the cloud resources to get the latest threat information, to be able to make sure they know what those signatures are, to be able to do that deep inspection. Again, we're going to talk a lot more about firewalls in their own lesson. Next, we have IDS and IPS, which is intrusion detection systems or intrusion prevention systems. IDSs and IPSs can recognize attacks through signatures and anomalies. They can also recognize and respond if they're an IPS. Now, a detection one can only see it and log it. But if you're using a protection one, they can actually see it, log it, and then try to stop it by shutting off ports and protocols. These IDS and IPSs can be host-based or network-based devices, depending on how you want to set it up in your network. And they're going to be on one of these two lines going left and right with a circle through them. This is considered an IDS or an IPS sensor, and it's the same diagram that's going to be used for both of these devices. The only difference is you'll see an IDS or IPS written on it to dictate which one it is in the diagram. Again, we're going to talk more about IDS and IPS in depth in their own video because they're really important to the security of our networks. Next, we have a proxy server, and this is another type of specialized device, and this one is going to make requests to an external network on behalf of a client. Essentially, it's a middleman or a go-between. Now, why would we want to do that? Well, there's really two functions. The first was for security because it can perform content filtering and logging. On my network, I have a proxy server in my home network. So if my kids are trying to go online, it actually goes to the proxy server first. It checks what's allowable for them, and then it decides whether or not to let them go out or not. For instance, if they try to go to a pornographic website, it's going to block that. If they try to go to Disney Channel, it's going to allow that. Now, workstation clients are going to be configured so that all their traffic is going to have to go through a proxy server in your corporate network. Here you can see this on the diagram that if my son's computer and he wants to go make a request, he's going to go to the proxy server. Then the proxy server is going to check if it's on the allowable list. If it is, it goes out to something like disneychannel.com, gets the information, brings it back to the proxy server, and then the proxy server gives it back to my kid. That would be function one. Now the second function of a proxy server is they can have a cache in there and actually store a copy of that information that was requested by the user. In my case, I have two kids. Let's say my son goes to Disney Channel, and then right after, my other son decides he wants to go to Disney Channel. Well, the proxy server already made that request and has it locally. So once it gave it to my first son, it can then give it to my other son without even having to go back out to the internet again, and this saves bandwidth and saves resources and time. Proxy servers are really good at that, but they are not the best. Instead, we have another device out there which is called a content engine. These are dedicated devices that are there just to do caching functions of a proxy server. They're basically more efficient than a proxy server when it comes to caching, and we call them content engines or caching engines. Where there's really going to be a big benefit here is if you have a big headquarters with a big beefy internet pipe. But then you have this small branch office kind of in the middle of nowhere, and it's really expensive for a good internet connection. If you have a lot of data that goes across a small pipe like a VPN or a leased line, this can actually be a big data bog and slow down inside of your network. So what you'd want to do is put a content engine at the branch office. This way, in the middle of the night, the headquarters can actually sync up data and update that content engine, and then during the day, anytime somebody requests that information, they get it locally from that office with the content engine, and that way they're getting it over gigabit Ethernet instead of going up a slow dial-up or a leased line connection back to the head office. Now, this is a very, very useful thing to use inside a remote branch office. Otherwise, if you're in a big headquarters and there's a big branch office that has a big pipe, you probably don't need a content engine because you can just go out over the large connection of the WAN and get that information from the headquarters. Again, if you're trying to speed up local access, content engines are really good for that. Next, we have a content switch. This is also known as a load balancer. Now, a content switch or load balancer is going to distribute your incoming requests across various servers in a server farm. This is why we call it a load balancer, because they're balancing the load. Now, why do we need these? Well, let's take the example of Amazon.com. Do you think Amazon.com can handle all of the amount of traffic it gets on a daily basis with just one physical server? Of course not. They have millions of users accessing their content all at the same time. Instead, they have server farms with hundreds and thousands of servers out there. And all of these have to be able to answer up for a single domain name, Amazon.com. And that's where the content switch comes in. When you go to Amazon.com, it actually goes through their router and to their content switch. And then it starts handing out those requests to different servers. If it's a big task, it might actually split that up across 20 different servers. For example, if I have a big task at work to do, I can actually break that down into pieces and give it out to 20 different people to help me get it done. In this case, I would be acting as the content switch. I break the load down to small parts and hand it out. So my boss comes to me and said, hey, here are 100 things I need done. I would then break those apart and give 4 or 5 to each person and hand them out, and that way they can start doing the work. When they're done with it, they hand it back to me, I consolidate it, and then I give it back to my boss. That's essentially what a content switch is doing. It's handing out those requests to different people based on their ability to perform the workload. In this case, those people are servers. That's exactly what a load balancer or content switch does. It's going to send the requests and distribute the workload across all the different servers in order to provide the best response times and prevent a single server from becoming too overloaded. Other devices. In this lesson, we're going to take a quick look at some devices you may find on your networks. This includes things like VoIP phones, printers, access control devices, cameras, HVACs, Internet of Things, ICS, and SCADA devices. First, we have VoIP phones. A VoIP phone is a voice over internet protocol phone, and it's a hardware device that connects to your IP network in order to make a connection to a call manager within your network. Now, a call manager, also known as a unified communications manager or a unified call manager in Cisco-based networks, is going to be used to perform the call processing for hardware and software-based IP phones. Now, if you have an IP phone, you can call another IP phone directly. There's no issue with that. For example, if you have VoIP phones in your office building and they're all connected to your local area network, you could pick up a phone and dial another phone and talk to your coworkers. But if you want to be able to talk to your spouse on their cell phone, you have to configure your call manager to route those calls to the public telephone network by connecting it with a telephone provider. VoIP systems are very popular these days because they lower the cost of long distance and it allows you to provide encrypted voice lines within your own companies if you're doing VoIP to VoIP calls. Now, VoIP phones often look like a regular phone, but they may also include a digital display or a video camera so you can make face-to-face calls as well. The next device we're going to talk about are printers. Now, if you've already taken your A+ exam or you've ever printed out a document, you already know what a printer is. Printers can be directly connected to a computer using USB, or they can be connected to your network and shared by multiple users. When it comes to network printers, they can be wired or wireless, and you have the ability to configure them with the right IP address statically or by using DHCP. This way, they can connect to the network and other users can connect to them as well. Next, we have physical access control devices, which includes things like security gates and turnstiles and door locks and many others. All of these things are often connected to a network, and when they're connected to the network, they're often going to be on their own network for additional security, not connected to your corporate network. Now, if you do connect them to your corporate network, you need to make sure you place them in their own VLAN. This will give you additional security controls and safety. But for the most secure environment, you really should have them on their own separate physical network. Next, we have security cameras. Often, these will be connected to your security network, just like your physical access control devices. But in a lot of small office or home office environments, you may have them connected to your corporate network as well. This way, they can access the internet and you don't have a bunch of extra gear to have to pay for. Again though, if you're going to do this, I highly recommend getting some additional security, like putting them on a separate VLAN and adding ACLs to protect them. Traditionally, security cameras can actually be very insecure devices just because they're part of the greater Internet of Things, and it's risky to have them on your enterprise or corporate networks. Next, we have heating, ventilation, and air conditioning, or HVAC. There are going to be lots of different sensors and controllers to help work with these things. These, like security cameras, should be placed on their own VLAN and have security protections in place. These HVAC sensors and controllers are going to be useful to have on a network so you can detect the temperature and humidity of the spaces that people don't work in daily, like server rooms and communication closets. But again, these devices tend to not have a lot of security built in, so you need to put additional protections and defenses in place when you connect them to your network. Just like security cameras and HVAC sensors, there is a whole host of other devices you may find attached to your network. We call these the Internet of Things. This is things like smart TVs and smart watches, smart refrigerators and smart speakers, smart thermostats and smart doorbells, and many others. All of these things are part of IoT, or the Internet of Things. Just like I said for HVAC and security cameras, you should be putting these devices on a corporate network or enterprise network in their own segmented VLAN or on a separate network altogether to be able to give yourself more protection. Finally, we have ICS and SCADA. ICS stands for Industrial Control System, and SCADA stands for Supervisory Control and Data Acquisition. When we talk about ICS or Industrial Control Systems, this is a term that's used to describe different types of control systems and the associated instrumentation. This includes devices, systems, networks, and controls that are used to operate and automate industrial processes. Now, the specific type is going to depend on your industry, but normally this includes electronic sensors and equipment that are built specifically to have an effect on the physical world. I mentioned earlier the term SCADA. Well, SCADA is one type of industrial control system, or ICS. For example, I used to work as a nuclear reactor operator early in my life. Now, when I was sitting at the reactor plant control panel, there were a lot of pressure and sensor gauges that I would monitor and lots of different switches that I could turn to turn things on, like pumps and heaters. SCADA systems allowed me to take all that data and put it in one place. I could acquire it and transmit the data from all these different systems and put it all into a central panel so that I, as a reactor operator, could monitor and control it. Now, I didn't have to sit inside the nuclear reactor or next to the reactor to turn on the coolant pump. Instead, I could be safely away from all that radiation and be able to control and see everything using these SCADA systems. That way, we can actually also do things like automation. We could set a range of values that a programmable logic controller could take, and that way, if we need to turn the pump on at a certain temperature or off at a certain temperature, we could do that too to keep the reactor at the right temperature for safe operations. Now, why is this important to consider ICS and SCADA systems as a network engineer? Well, because these things run on networks too, and you may be asked to work as a network technician at a reactor plant, or an automobile factory, or an oil pipeline. then all of these sensors need to be connected, and that happens using a network. Again, like IoT, I highly recommend you have a separate or segmented network for your ICS and SCADA devices. The reason for this is that these things are very sensitive and they need to be protected. I don't want my reactor plant connected to my email server. That's a bad day, because if somebody has a malicious email and it infects our systems with ransomware, it can make it so I'm locked out of my ICS and SCADA systems and won't be able to control the reactor too. So we don't want that. You need to have it on a separate network. All right, for the exam, I want you to remember there are lots of different things that you might work on as a network technician. This includes things like VoIP phones, printers, access control devices, cameras, HVACs, Internet of Things, ICS, and SCADA devices. Each of these devices is going to bring risk to your networks and to the devices themselves. So you have to weigh the operations and the security as you're building security into your networks and figuring out where to place these devices.